Hello everyone, I am Sujani Jaykumar. I will be giving a demonstration about the research that I have been working on for my final year project. The topic of my research is a remote health companion for provisioning the possibility of being diagnosed with PCOS by analyzing lifestyle and behavioral data. I will be talking about the problem background, the gap I identified, the proposed solution with the help of an architecture diagram, then a demo of the core functionality of my project, and finally about the future plan that I am looking forward to complete before the final submission deadline. Let's start with the problem background. Together, technology and humanity can create a path for better healthcare and services. Machine learning is a subset of artificial intelligence that allows the system to learn and improve on its own without having to be explicitly programmed. It mainly focuses on the development of algorithms that can access the datasets provided and utilize the data for the learning purposes. Machine learning application in the health industry includes detection, data prediction, and image identification, among other things. Women get to experience difficulties that are more prone to life and distinctive than men. There can be some disorders that can be found within men but not in women, and vice versa. So, what is PCOS? In simple terms, polycystic ovarian syndrome is a heterogeneous endocrine condition that affects most of the women in their childbearing age. Stein and Leventhal became the first to report this syndrome in 1935. This syndrome develops around 5 to 10% of the women who are in their reproductive age around the world. The exact cause of PCOS is not yet well established, but doctors and researchers have found out that it is caused by a combination of environmental and genetic factors. One of the primary causes for this condition is the high levels of male hormones called androgens. All women make small levels of androgens, but in the case of PCOS, abnormally high levels are made, and due to this, the ovaries are blocked from releasing an egg. PCOS can further lead to infertility, type 2 diabetes, endometrial cancer, metabolic syndrome, depression, high blood pressure, high cholesterol, heart disease, and stroke later in life if undiagnosed. The common symptoms of PCOS are irregular periods, excess male hormones, excess hair growth in body, excess weight gain, and infertility. So, it is critical to evaluate patients at an early stage to avoid any major disease complications. Most of the PCOS symptoms related to lifestyle and behavioral factors of women. Few of them are remain in our control since some of them are not. Obesity, high blood sugar levels, reproductive health, lack of exercise, poor diet, smoking and stress are some of the factors that can be controlled by women, and it will create a significant impact on increasing the possibility of getting PCOS. Around half of the patients who stick to their lifestyle modification see an improvement in menstrual cycle regularity and ovulation. This study focuses on building up an ensemble based health companion for predicting the possibilities of getting diagnosed with PCOS in its early stages using the advantage of correlation between clinical symptoms and lifestyle factors, which make the process easy about being aware of their health condition. Next, I am going to explain about the research gap identified with the support of LR. PCOS is a condition that rarely affects women who have achieved puberty and going through their childbearing age. Most of the women are unaware of this syndrome until they get diagnosed with PCOS itself. Women diagnosed with PCOS are mostly identified with clinical deficiencies such as the abnormal amount of androgen hormones, tiny cysts around the ovaries, etc. Studies prove that these clinical deficiencies can be triggered and influenced by certain lifestyle factors such as age, overweight, and improper food consumption, etc. Early diagnosis of this condition and proper care increases the possibility to get cured. providing a solution to identify the possibilities of getting diagnosed with PCOS using the correlation between the clinical symptoms and the lifestyle factors will be helpful for the users to be aware of their health condition. The identified correlation between the general lifestyle factors and PCOS clinical symptoms will be helpful to predict the possibilities of getting diagnosed with PCOS. To identify the possibility as a value, a classification algorithm should be used. Many past researchers have explored with many data mining techniques and classification algorithms for predicting the risk of being diagnosed with PCOS diagnosis. So in this research, I have selected ensemble approach to predict the risk of being diagnosed with PCOS rather than using standalone machine learning algorithms. In simple terms, ensemble techniques create multiple models and then combine them to produce improved results. Ensemble method usually produces more accurate solution than a single model would. After predicting the results, the user will be informed about which lifestyle factors has influenced more in the prediction results. In order to identify the relationship between the input and output values, the partial correlation coefficient will be used and the input variable with higher correlation value with the output will be decided as the most influencing factors for the prediction results. Nowadays, mobile phones are seen in people's daily lives. As people live in the technological world, the devices have become a necessity in every human being. Just like the surroundings around people, such as friends, mobile devices, have both positive and negative effects in people's lives. Such PCOS related awareness can be easily conveyed to the general public through a mobile based solution will be more effective in the current situation. So my proposed solution for the problem is a mobile-based health companion, early diagnosis of PCOS, and related content and ensemble learning approach for predicting risk of PCOS. The proposed system's three-tier architectural diagram contains presentation tier, logic tier, and data tier. The presentation tier has 6 wizards. The account registration wizard will be the very first page to the user where the user can register and explore the mobile application. Factors input wizard will ask the user to input the necessary data which is required for the prediction process by asking relevant questions because the system is completely dependent on the user's input. After the user gives the necessary inputs to the system, the prediction wizard will take place. Right after the system makes the prediction, it considers the possibility percentage rate and using the medical advice wizard, it will advise the user on appropriate medical measures and monthly wizard responsible for displaying the complete analysis of the user's risk factors using past data. Displaying the complete analysis of the user's risk factors using the past data. Under logic tier, core module is for predicting the probability of the PCOS condition risk using an ensemble learning classification model with the help of users' lifestyle and behavioral factors. And optional module is responsible for predicting the probability of the PCOS condition risk using an ensemble learning classification model with the help of users' lifestyle and behavioral factors. Under the data tier, user information database contain data about the user. So these necessary data will be obtained from the database, which was created from all the details given by the user and will be used in the prediction process. Now it's time for the demo. In the first block, the important machine learning libraries that are used to build this core functionality were imported to the notebook environment. The library names are Pandas, NumPy, Matplotlib, Seaborn, TensorFlow, and Keras. In the second block, the dataset been loaded into a form of data frame object. Data frame is an object provided by the Pandas library, which is used to import and manipulate dataset. Since the dataset we have is in a form of an Excel sheet, the read Excel method is used to import the dataset as a data frame object. In the next block, unwanted columns created while importing the dataset as a data frame was removed using drop method of the data frame class. Next, there were two columns with non-numeric data was identified when importing the data set since the data that we needed to provide to train the machine learning model should be numeric type, so the data of those two columns were converted into numeric type data. Then there were columns identified with null values. Since there should not be any null values while training the model, the data block that had the null values was filled with the relevant features median value derived from the provided data. In the next block, I drop the columns which are related to clinical data factors from the data frame object, because the aim of the project is to predict PCOS risk using lifestyle and behavioral data. Then in the next block, the info method is used to view the summary of the data frame object after executing the above mentioned code to prepare the dataset for training the model. According to the summary, there are 595 entries of the user with PCOS classification as 1 or 0, and only lifestyle and behavioral factors used to determine the answer. In the next block, the number of counts of each classes were visualized using a bar plot which is provided by the Seaborn library. According to the graph, there was a target variable count imbalance was identified in the original dataset. The imbalanced behavior in the target variable count will direct the training toward a biased behavior towards the class that is high in count, so this problem needed to be sorted. As first step, the original data set splitted into two variables as x and y. Y represents the final output class, which is PCOS, yes or no, and X represents the input column data other than PCOS final results. In order to resolve the class imbalance problem, there are two solutions available. One is undersampling and other one is oversampling. Reducing the number of data rows equally to the number of class, which is low in count, is called as undersampling, and increasing number of data rows to the number of class, which is high in count, is called oversampling. I choose oversampling as a solution because oversampling increases the total number of data rows. By randomly duplicating the data of the class which has the least count, and also it is better to have high number of data rows in the total data set as much as possible. A library named IMB Learned provides the pre-built implementation for random oversampling, so I use that library to do this implementation. After oversampling, the data frame has total number of 776 data. In the next block, the splitting of training and testing dataset was conducted. In order to do this process, a pre-built implementation called train test split provided by scikit-learn was utilized. The testing data size was chosen as the 25% of the original dataset. According to that, variables such as xtrain, xtest, ytrain, ytest were obtained. In order to train the model, the input data need to be pre-processed, which means scaled. To scale the data, a method called min-max scaler provided by the scikit-learn library is used. It scales all the input numeric data into a range of 0 to 1. As our first try to train a model, the gradient boosting classifier model is imported using scikit-learn library along with some evaluation metrics methods such as accuracy score, confusion metrics, and classification report. Then the gradient boosting classifier model is created and trained using the training data by calling the fit method. In order to evaluate the performance of the model, the input test data X test was cast into predict method, which outputs the predict results to the input dataset. Then the model evaluation was performed by passing the actual and predicted test data to the imported evaluation metrics. According to the classification report, the accuracy of the gradient boosting classifier is calculated as 89% and the confusion metrics also outputted. Next, the light GBM model was imported, trained, and evaluated. The accuracy of the model was derived to 90%, better than the normal gradient boosting classifier. According to the evaluation, the light GBM model was chosen as the ensemble model. As a practice, I tried to build the ANN model from the scratch using TensorFlow and Keras. So the relevant libraries was imported, then a sequential model was created and layered with 100 neurons were added according to the layers. There are one input layer, one output layer, and 3 hidden layers. The output layer has the activation function called sigmoid, and the other layers have used ReLU. Dropouts were used to avoid overfitting of the model. While compiling the model, Adam optimizer and binary chronotrophy were used as the optimizer and loss function. To avoid overfitting, the early stop mechanism was implemented, then the model was trained using training data. Then in the next block, the actual losses and validation loss of the model is visualized using a graph. In the next block, the prediction was made for the test data set and evaluated using the confusion matrix and the classification report. According to the classification report, the accuracy derived to 89%. Since the ensemble learning model that I chose to use does not support any models built using other frameworks, such as TensorFlow and Keras. A pre-built multi-layer perceptron classifier provided by the scikit-learn library was used to build the ANN model. Then, several combinations of hyperparameters have been tried, and finally, suitable parameter values identified and used to create the model. After creating the model, it was trained and evaluated. According to the classification report, the accuracy of the model was derived to 92%, which is a good accuracy. As the final step of ensemble model was created using voting classifier model, which is imported from scikit-learn library, and the multi-layer perceptron model and the light GBM model are provided as the estimators. Finally, the model was trained and evaluated. According to the classification report, the accuracy of the ensemble model is derived as 92%. Even though the precision of the target classes was increased, while prediction is done using the ensemble model. So, we conclude that the ensemble method performs better than multi-layer perceptron and light GBM models separately. The final topic I am going to discuss about is the future plan of my proposed system. The summarized future enhancements are given below. The first one is to increase the accuracy of the model using new combinations of hyperparameter tuning. The second future enhancement is implementing a full-fledged mobile application that includes the risk prediction as the core feature and several sub-features such as medical advices, monthly report, and forum in predicting the PCOS risk. The final future enhancement is making the mobile application public in various mobile operating platforms for real-world usage to increase the awareness about the PCOS among women. Thank you.